So this is topic 4. So these are the two, we're almost done with the parent function stuff. So we're going to talk about two graphs. So these are kind of difficult, all right? Especially this one. We talked about it a long time ago, but these are the important points, the key points. We have -1, 0, and this is undefined, all right? So that's what I mean by UND, undefined. And then we have 1, 1, okay? Now, what this graph looks like, this is a rational function or reciprocal function, whatever you want to call it. You have an x on the bottom, right? What's the only number you cannot divide by the way? 0, right? So what happens, that's what I put here. As you see how I put it undefined? Because if I try to divide by 0, that's undefined. It can't happen. Because of that, you have what's called a vertical asymptote right here. Right, so it's a dotted line. If you actually do this on your graphing calculator, this line is not really there. All right, it's just to help me graph it. But you also have what's called a horizontal asymptote. Now, the way I can explain the horizontal asymptote is to tell you this. Well, let me graph it first. I have 1, 1, -1, -1. Okay. Now, the closer I get to 0, x being 0, then the number gets bigger, bigger, and bigger, right? You understand that, right? That, I don't know, do you know that if you divide by a really small number, you get a bigger number? Like 1 divided by, I don't know, like 0.00001, you get a really large number. See what I'm saying? So it's kind of weird. So notice that the closer I get to this line, which is 0, the smaller this x gets, the bigger the y value. Okay, that's what you have there. Now, if I divide by a big number, what happens if I divide by a really big number?
You get a small answer.
I get a small answer, all right? And this is 1 times 10 to the -4. But am I ever going to be 0? If I divide by a bigger and bigger number, I get really, really close to 0, but I will never get there, right? So that's why this one, as you divide by a bigger, notice the x is getting bigger to the right, but y is getting smaller and smaller and smaller. Hence, I'm getting close to the asymptotes. I'm just explaining why, but the reality is, you just have to know that's what that looks like. And then also on this side, same idea applies, except for you have negative numbers. But that's what that's going to look like, all right? So if you don't understand that explanation, that's fine. This is what it looks like. I was just trying to tell you why you have a vertical and horizontal asymptote, all right? So my domain can be any number. It can be any number except for what's the other thing I just told you cannot divide by? 0. So x cannot be equal to 0. All right, so x cannot be equal to 0. Now on the range, no matter what x I plug in there, it doesn't matter what x I plug in there. It can be the biggest x that I can have. I will never have 0 for the range, and that's why the horizontal asymptote is here. I can never cross that horizontal asymptote. So because of that, y cannot be equal to 0. Another way to explain for you a horizontal asymptote, by the way, would be like your grade. Right? What's the highest grade you can have?
100.
100, right? Now, if you're getting really, really close to 100 and you make like an 80, that kind of brings down your grade a lot more. It's really hard to get to 100 if you're at a 99. It's really hard because you have this horizontal asymptote. You keep trying to go up, but you can't. Really, really slowly. But then you make a 70 and all of a sudden you just drop, right? That's because of that, because they have a horizontal asymptote. Another way to think about it is free throw percentage. What's the biggest free throw percentage you can have if you watch basketball? Have you ever seen like, oh, he's got a 83 or 0.83 free throw percentage? Everybody watch basketball, baseball, anybody? Nobody watch sports? Football? Well, football is a little different, but on basketball, the best you can do is to hit, when you walk up to the line, is to make every free throw. And that's a free throw percentage of 1 or 100%, which rarely ever happens. Actually, never happens, okay? So, anyway, that's enough for that. You just have to remember what that looks like, all right? The vertical asymptote is always going to be the same as the domain, except for it's going to be x is equal to 0. And on the horizontal asymptote, you're going to have y is equal to 0. Right, so notice that these have to be the same, except for you have a different, you have a not equal to here, and you have an equal to, right? Now moving on to a different type of function. This is called a cubic function. Right, on the cubic function, I'm going to give you these points right here. Now remember, how do I get the y coordinates of this? Yeah, I just cube them, right? What's negative 2 cubed? Negative 8. Right? So it's negative 2 times negative 2 times negative 2. So that's negative 8. That's where I'm getting this from. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. All right, so don't forget where I'm getting those numbers. All right. So now I'm going to go ahead and graph that. I have 0, 0 right there. 1, 1. And then I have 2, 8. So from here, you go 2 and then up 8. All right, so I'm going to be right here. Then I also have negative 1, negative 1. And negative 2, negative 8. Alright, just like that. That's what that looks like. Alright, let's talk about the range. The range is easier to see. What is the range of this? What do you think?
Is it negative infinity, positive infinity?
Negative infinity to positive infinity, very good, which is all real numbers, right? Domain kind of harder to see, but as you go up, you go farther to, let's see, which way are you looking at this? Well, let me do it like that, so I'm symmetric. The farther you go to your right, the farther you go up, the more right you go. The farther you go down, the farther left you go. So this one also happens to be all real numbers. That's what I'm trying to tell you. It just goes there a lot slower. Okay. So, look. I'm going to take a little break right here just to tell you this. On the quiz, or on the test actually, the hardest part for you is not so much this, because I know that I've seen you work, and most of you, if I give you one graph, you know how to do that. But once I start mixing up all the graphs, that's when you get confused. Okay? So always remember that a quadratic function looks like a guy giving you a touchdown sign. Alright? It always looks like a parabola. So x squared looks like this. What about negative x squared? It looks like that. Have you ever seen anybody has seen Tommy Boy by any chance? The movie with Chris Farley? Well, if you've never seen it, he puts a tiny little, he's a fat guy, and he puts a tiny little coat, like barely fits him. And he's walking around like this, and he's just going, fat man in a little suit. Anyways, that's what it reminds me. Alright, so touchdown, positive, quadratic, negative quadratic, right? And when I talk about quadratic, I'm talking about, and sorry if you're listening to this on video, you're not going to see this, but I'm talking about this. If it has a square on it, it's either going to look like this if it's positive, like this if it's negative, right? Now, this one's kind of hard to see. You have y is equal to the square root of x. It kind of looks like this. Well, if you're looking at me, I'm a mirror, all right? It'd be like this. Right, for you, it actually be like that. It's always going to the right. It's kind of like this parabola, except without this arm, and I'm throwing this on its side. That was kind of hard to see. Okay, whatever. But the absolute value, you should know. Absolute value looks like a straight V. It looks like a V for victory. What about a negative?
Upside down V.
Upside down, right? So it's pointing down. Don't forget that. A lot of people on your quiz, you even wrote me the right points. But then you had the completely different graph. All right? If it's an absolute value, I don't care how complicated this gets, it's always going to look like a V. Always. Okay? If you have this one right here, well, this one is what I just taught, right? And the last one, that's a cubic. Well, the cubic either looks like this, if it's positive. I'm right-handed, so I always think the right hand should be the positive side. Do I have any left-handed people? Sorry, it's the way it is. You live in a right-handed world. All right, so this is positive, and the negative is just the other way, just like this. So positive cubic, negative cubic. Why don't you do that for me? A little bit of exercise. Touchdown quadratic. Come on, don't be shy. I know we don't look stupid. I'm here in front of you. All right, quadratic. Negative quadratic. All right, now let's talk about absolute value positive. Negative absolute value, down. Now the cubic is the hardest one. Cubic. Positive, cubic, negative. Positive, negative, positive, negative. All right, don't take any videos here. All right. Now, if you ever had, that's what I mean that because I'm right-handed, I always think of positive. So if you're sitting there, I'm like, I have this function, but I don't know what that looks like. Well, I can't remember if it's like this or like this. I always think right hand is positive. Okay. Now, if you still don't remember that, think of a linear function. What does a positive slope on a line looks like? It's like this. It's a line. Just bend your arms. That's the same thing. positive, negative, okay? Don't forget. All right, moving on with the lesson. Again, if you're watching the video, you just missed a great lesson. But that's okay, nobody's gonna watch this anyway. That's what you're gonna fail. All right. So let's look at this one right here. Knowing what we know. All right. What type of effect does this have on the parent function? On this one, is it up 3 or is it to the left 3?
Up 3.
Up 3. All right. So, and you can see the difference here. This is up 3. Now, if it's underneath in the denominator, then that's going to be to the right 2. All right. So if it's underneath, that's going to be right or left. So on this one, don't forget that this is right 2. Okay. What about this one? What does that negative do? Reflects. And then finally, this combination, we have left 2, right? If it's underneath here, it's left 2, down 3. Right now, again, these are the rational functions. All right, let's take a look at these other ones right here. We have 2x cubed. What does that 2 do to it? Vertical stretch, right? Vertical stretch. Is it really for me? Okay. What about this one right here?
You would go to the left 3.
Correct. Left 3. Now, you remember what that one looks like? Alright, so it looks like this, and you're just moving it to the left. Sorry, to your left 3. So again, I'm just going to write left 3 though. This is right 3. This is up 1. Right, so I'm going through it kind of fast because you should know that by now. Alright, that's going to be reflect. And then down 5. Okay? Alright. Without a graphing calculator, we're going to graph this. Alright, so we have reflect up 3, right? So up 3, instead of actually trying to move the points, because the points are not actually there, I'm going to move the asymptotes. Remember they had an asymptote here and here? I'm going to move that up 3, so we have 1, 2, 3. And I'm going to draw myself a little dotted line that tells me, okay, that's where the asymptotes are at now. So it's basically like moving the crosshairs. Alright, so now I think this is a little bit easier to see that this is my fake origin now. And the only points you need to remember are this one, they're easy. It's 1, 1, negative 1, negative 1. But, alright, so I'm going to write this here, negative 1, negative 1. This is 0 undefined, as it should be. And this is 1, 1. However, because we have that reflection, we have that negative, we're going to multiply all of these times that negative 1. That looks like x minus 1. I apologize. You can put a dot there if you want to. Whatever. My point is this is going to be 1 undefined still, and this is going to be negative 1. So in this one we have 1, negative 1. So 1, negative 1 is right here. Right? Assuming that's the origin. Then we have negative 1, positive 1. So negative 1, positive 1. Right there. And then you just get really, really close to those asymptotes. Don't cross them. Don't go through them. Just get really close to them. What's the domain? Did I move left or right? I didn't move left or right, correct? So this is still, x cannot be equal to 0. Now, there's one thing that you should know. This line right here, this vertical asymptote, that's x is equal to 0. That's hard for some people to understand because that's the y-axis, but that's the line x is equal to 0. And this line right here is y is equal to 3, which also happens to be my range. Y cannot be equal to 3. Okay? So my vertical asymptote is located at x is equal to 0. My horizontal asymptote is located at y is equal to 3. Okay? Kind of weird. Let's move on to the back. Right, I'll just do a couple of these, by the way, on the quiz also. Always start off with this, alright? I'm trying to tell you what graph to use. So if I tell you to use this, but you use the square root, then you did it wrong. Alright, this one. So we're going to start off with that. shift 3 units to the right, so we have x minus 3, right? X is a liar, so I have to go below that. Then it says 5 units down, so minus 5. It also says reflect. So we're going to put a little negative out here. One more. Start with x cubed, right? So we have to have an x cubed there. Reflect across the x-axis, so we have a negative. Stretch by a factor of 3. Well, we're going to write a 3 right here. And shift to the left 2. So x plus 2. Now, since it told us to start with that, I need to put a cube right here. Now, 3 through 6, I'm actually just going to ignore it. Okay, I assume you can do this. If not, I can help you in your homework. So let's go to these, because these are a little bit different. All right, now on this one, don't count to that point or that point. Don't do that. There's a vertical and a horizontal asymptote. They just don't put it there because technically it's not even there. Right, but I will put my vertical asymptote right here. Now I'm going to put my horizontal asymptote right here. And then now all you have to do is see how many spaces from the origin did I go to the right and how many spaces did I go up. So how far to the right did I go?
3.
3.
2.
No, you're right, 3. And then how far up?
4.
1, 2, 3, 4. Remember, I'm counting to the line. Right, so I'm counting to this middle part that's not even there for you. So right here, because this is a rational function, I guess, should be able to recognize that. We have 1 over x, what is it? Minus 3 plus 4. All right, on number 2, we have a vertical asymptote right here. We have a horizontal asymptote right here. All right, so I want you to give me the equation of for this one. We have 1 over x something something. And by the way, you don't have to worry about these being stretched. There never are. On this lesson, they never stretch them or shrink them. Right? Because that's kind of weird. Like I said, no, don't throw that at him. Let him sleep. Let him sleep. It's fine. All right. Someone will volunteer. How far to the left did I move? 7, right? So plus 7, because remember x is a liar. How far up did I move? 3. Yep. Okay. And remember, on these, they're not going to be shrink or stretched. They could be reflected, but this one's not. And again, I know I'm not being reflected because the very first point is 1, 1. See from here? 1, 1. It's right there. Right, now these are my faves. These are the cubic. All right. By the way, let's do number 4 first. Yeah. So on this one, you have to come to this middle point, which is normally 0, 0, and you have to figure out how far to the left and how far to the right did I go. Sorry, how far to the right and how far up did I go. So how far to the right? 4. And remember, this is a cubic, so you want to write a cube there. And how far up did I go? 2. Okay. Is this being reflected? Now, if you don't know, raise your right hand. It's not being reflected because this is positive. All right. Now, this one right here, on number 3, I know that was a confusing statement. This one is reflected, right? It's negative because left arm up. So this is negative. So before we can go any farther than that, negative. Let's see, how far to the left? 1, 2, 3. So we have x plus 3. I had to think about that one way too hard. Cubic plus 2. Right, so don't forget, these are the cubics, like this, all right, either one for you. All right, so what I'm going to do now is I'm going to pass back your quiz. Actually, let's take a look at the homework real fast. Alright, notice that on the homework, the first three up here, they're rational functions, alright? So those are the new ones that I just taught you. Now, this one right here, what type of function do I have? Cubic. How do we know this? Because there's a cubic right here, right? There's a to the power of 3, so if we have something to the power of 3, we have something that's cubic. Cubic, right? So, by the way, what is that one going to look like generally? Right or left? Left and up, right? Because it's negative. So make sure it looks, gotta look like that. That one, negative. Gotta look like this. That one, positive. Gotta look like that. Alright, so you have to always think about that. Alright, what about number 7? Do you remember what number 7 would look like? That was kind of the hard one. Yeah, it's kind of like this. I see you doing this. Right, it's the one that kind of does this, right? Some people are doing this. I can't do this, alright? I have to break my hip if I do it. Pull the muscle just now. Alright. So yeah, that one looks like this. I'm going to erase this screen so you can see it. It's going to look like that. Right? What about number 8? But it's negative. So it's like this, right? It's down. It's got to be pointing down. And it's being stretched, so if it's being stretched, it's actually going to be even narrow. It's going to narrow down. Okay? And then finally, number 9. Touchdown, baby. Alright? That's it. Alright, so make sure you know this. Alright, so what I'm going to do now is I'm going to give you back your quiz and I want you to correct it. So you might want to do that first. If you can turn in today, turn in today, but if not tomorrow, I'll give you half of your points back. Alright, so make sure you know how to do this. Or not. Up to you. Peace be with you. I can't find the remote to stop the recording. What do I do with it?